All right, here's the math from the review. When you're doing a problem like this where you're dropping something straight down, remember that you have to underline all your givens. 9.5 seconds, that's time. You're also always given the thing that makes this accelerate, right? G is equal to 10 meters per second squared. We're going to use 10 on the test tomorrow. All right. Let's see. So if we're looking for the V final, I need to use the guess method. I can use the quick guess method. So let's see. I have G, I have T. Which one of these equations will get me V, or velocity with just G and T? Right here. Okay. So that's velocity equals 10 times your time, which was 9.5. Okay, so that's 95 meters per second when you do the math. Make sure you get your units. Okay, the distance or the height. So distance, using my givens here, I've got G, I have T. What's my V initial in the Y direction? V initial, I have that too, right? My V initial is what? 0. Okay, so which one of these will get me that kind of distance? And this is 0, so this goes away. I can use this equation. Okay, so the distance in the Y direction, or the height, is 1/2 gt squared. Always use the equation first so you know what you're doing. Okay, 10 is g, and my time is 9.5. We're going to square that. Okay, so you end up getting, do all the math, 451.25 meters. Acceleration final, you really shouldn't have to think about that. Acceleration is going to be the same, 10 meters per second squared. Okay. Velocity at 5 seconds, that's this equation up here. Velocity equals g times t, which is 10 times 5 seconds, so that's 50 meters per second. All right. What's the distance at 5 seconds? That's the same equation as earlier. Distance equals 1/2 gt squared, so that's 1/2 10 times 5 squared, 125 meters. All right, move down here, so parabola, here we go. Time to reach max height. So let's see, what are my givens? I have a velocity. I also have 5. I got g, right, which is always 10, or negative 10 since if up is positive, which this velocity is positive, that means down would have to be negative, right? So g is going to be negative 10 meters per second squared. And that's it, right? So what equation can I find time given velocity and gravity? Time, velocity, and a is also equal to g, right? So a equals v over t. I need to solve for t, so we can swap these out, right? T equals v over a, so that's 55 over 10, that's acceleration due to gravity. The time to reach max height is 5.5 seconds. Okay, the max height, now this is a d in the y direction, right? This is 1/2 gt squared, right? No, because I have an initial velocity that's not 0 this time. So I can't cut this equation in half. Velocity initial times time plus 1/2 gt squared. So that's going to be, velocity initial is 55 times your time, which is 5.5 seconds, plus 1/2. Your g is negative though, right? Negative 10 times 5.5 squared. 5.5 squared. So on that one you end up getting 151.25. 151.25 meters. Hang time is always just double the max height time, so it's 11 seconds. A final relative to the initial is negative 10 meters per second squared. We did all these maths earlier. I'm not going to do them right now. I just want to show you the math. Here we go. What equation do you use to find time? This guy right here. What equation do you use to find horizontal distance? It's this, except you don't have g, right? In the horizontal direction, you don't have gravity, so this goes away. So this equation is distance equals the initial times time only, okay, horizontal. So I'd have to use 8. What do you need to find first? You need to find time first. Time to hit the ground, so time is equal to square root of 2 times your distance divided by gravity, which is square root of 2 times 180 over 10. So this comes out to 6 seconds. Okay, distance from the base of the cliff, distance equals, remember we said it's this equation, you can't use gravity for this one. Okay, your velocity in the horizontal direction is 8. And your time is 6 seconds it's going to be in the air, so it's 48 meters. This was the lab we did, the projectile lab we did with the ball off the table. Okay, good job. Good luck.